Hi, my name is Berman. I'm an honours student here at the University of Western Australia, and this summer I undertook a research internship at the Pawsey Supercomputing Research Centre. Growing up in Israel, I was always madly passionate about soccer. I loved playing it growing up, whether it was with family, friends, at school, at home, anywhere. It was my biggest passion at a young age, and it's a passion which still burns in me to this day. While I was growing up, I also developed a love for numbers. Math was a subject I enjoyed a lot at school, and I loved using numbers to make sense of the world around me. The intersection of those two passions, soccer and math, also manifested from quite an early age in things like me playing an online football manager game, and then at the end of each season getting out a pen and paper and actually graphing the trajectory of my team throughout the season. It is a passion which has also carried me to pursue an honours degree here in applied mathematics at UWA. And it's also the passion that has brought me here to the Pawsey Supercomputing Research Centre. When I heard that Pawsey offered a project where I could use machine learning algorithms to study soccer matches and make more sense of them and recommend live substitutions, I was immediately intrigued. So this summer I worked with Dr. Sajid Mistry and Professor Anish Krishna on recommending substitutions in live soccer analytics. We used Topaz, a supercomputer offered by Pawsey, for most of our calculations. Firstly, we created parsing networks and calculated a host of network metrics such as degree, betweenness, closeness, clustering, eigenvector centralities, and entropy, and examined how these changed over the course of the game. We also developed a measure of how each of the players performed in each of the 6 network metrics during a game and added them to other in-match features of the players developed by last year's Pawsey intern, Jordan Atkins, who did a similar project. This created a detailed representation of the performance of each player in each game. We then used machine learning algorithms such as XGBoost and Forest Deep Neural Networks to correlate these metrics to match outcomes and achieve results that can classify match outcomes such as win, draw or loss correctly 67% of the time, double what you would if you were guessing randomly. We then started to develop substitution models. The first was based on maximizing the win predictions according to XGBoost and substituting the player which caused the biggest increase in win prediction when substituted on. The second was to cluster particular game styles together using a k-means algorithm and based on what cluster your opponent is, determine what cluster is most ideal for you to be in and suggest a substitution which minimizes the Euclidean distance to that cluster centroid. This is the very first time automated substitution models have been created, making this a very exciting growth area with many future possibilities. Maybe one day we'll actually see a little robot virtual assistant next to a coach, offering substitutions at the right time based on real data analysis, giving teams a competitive edge in a crunch moment. My goal in life is to further pursue a career where I can make sense of the world using numbers, data and analytics and create real and positive change. I'm grateful to Pawsey for granting me this opportunity and aiding me in developing my computing and research skills.